Yeah. Hey, hello everyone. Yeah, today we are trying to solve some selected problem of chapter 13 from the AoPS Volume 1. Okay, so the question number 222. So it mentioned equilateral triangle and the regular hexagon have equal perimeter. Okay, so that means for the regular hexagon and the equilateral have the equal perimeter, and if the area of the triangle is 2, so we know if it's A, right? We know it's the A over 2. Okay, so the the area of the triangle, excuse me, is 2 equals the root 3 over 4 of the A square, and this one is equal to the S is equal to the 6 times the root 3 over 4 times the A over 2 of the square. So this one equals the 6 times over 16 root 3 the A square, right? So now we can solve the A square here is equal to 8 over root 3, right? And the substitute into here is equal to 6 root 3, 16, 8 over root 3. You can cancel it, right? 2 is final answer 3. So this is very simple and straightforward. Okay, you just need to try to manipulating the relationship between them. So question number 226. So we have the S is the sum of the interior triangle of a polygon P, right? So polygon P, let's P is n sides, right? It's n gon. Then each interior angle is 7.5 times of the exterior angle, right? So now we can see is the, for example, the interior of the, we know the sum of the exterior angle, okay, is equal to 360 degrees because they finally get into a whole cycle. I give you example here for anything, right? So first we turn from here to this direction, right? This direction to this direction is angle of the x1, right? From this direction to this direction is angle of x2. From this direction to this direction is angle x3. This direction to this is angle x4. This direction to this is angle x5. And finally x6, we turn back to the original direction, right? So you can see you make a whole turn back to the original direction, right? That's this one. So that's why the x1 plus x2 plus the xn is equal to 360 degrees. Okay, now let's see the exterior angle. Okay, x2, let's see it's n gon xn, right? So the interior angle is 7.5 is of each one, right? 7.5 x2, then 7.5 of the xn. Then if you sum of this, it becomes 360. You sum of this, it becomes 7.5 times 360, right? Then it's right, 7.5 times 0.60 is equal to the of the n gon is n minus 2 times the 180. So that's why we have the 15 is equal to n minus 2. So n is 17. So we have a 17 gon, right? And of course, based on this arbitrary relationship, there's no restriction that you have to be irregular. Means there is no restriction. You have to restrict the x equals x1 equals x2 up to the x17. Okay, so this is this problem. So problem 227. So a regular polygon. Okay, now the regular polygon with exactly 20 diagonals. So this is the counting the number of diagonals. Okay, if you have an n gon, right, the counting the diagonals, you can see from a point of the A, right, you cannot draw the diagonal on its adjacent sides B and C, right? But for all the rest of them you can draw, right? So from A you can draw the diagonal of n minus 3, right? And you have the n of the point, right? And each diagonal, for example, A of the say the A and E will counting from the point A once, and will counting from the point E once. So that's why you double count it, right? So this one is equal to 20. So n minus 3 is equal to 40. So now you know the n equals. Now you know that n will be equals to 8. Okay, so now you know this is the octagon, right? This is a regular octagon, and we want to find we know the area of the octagon is 144 root 2, and we want to find the area of the circle, of the circumcircle, right? So now let's see. So this is the octagon. Okay, then for the octagon, it's a cutting. Regular octagon is a cutting from a square, right? So it's cutting from a square. So let's see, the size of the octagon is x. So it's 1 over 2 of x and 1 over 2 of the x, right? So now you know the s of the octagon is equal to the root 2 plus 1 of the x. The square of this is the square minus 4 of the half of the 1 over root 2 of the x times 1 over root 2 of the x. So this one equals to the 3 plus 2 root 2 of the x square, then minus the x square is equal to 2 plus 2 root 2 of the x square is equal to the 144 of the root 2. Okay, so now based on this we can solve the x, right? Now we want to see what's the area of the circle, right? So that's why we want to solve this radius, right? So the radius, now we know this angle is 45, this angle is 135, right? So we want to solve the radius. So to solve the radius, because we want to use some special angle of the 135, right? So if this is 135 and we know this is the each angle is 360 divided by 8 is equal to 45 degrees. Okay, so we know this one is 45 degrees, right? So this is 45 degrees and 45 degrees. So this is root 2r. Okay, now you can see, we can solve the r. Is basically, let's see, this is the ABC. Okay, so we already know what is the x. Let's solve the r. Okay, so we know this is the x, this is the x, this is the root 2 of the r, and this is the 135 degrees. So we have this triangle. Okay, x 135 and the root 2r. Then what you know is the 2r squared is equal to the x squared plus the x squared minus the 2 times x is cosine 135, right? Is the plus of the root 2. Then you can see is the 2 plus root 2 of the x squared, right? So now you see the r squared is equal to a half of the 2 plus root 2 of the x squared is equal to, now let's see what is the x squared. Okay, is equal to the root let's take out the 2 plus root 2 divided by 2, and 144 root 2, and this is the 2 of the 1 plus root 2. Okay, so now let's take out the root 2 here. Okay, this becomes the 1 plus root 2. Okay, now we can cancel out this, and here is 2. We can cancel this, so the answer is 72. Okay, so the important thing here is you need to know, I mean, the regular octagon is cutting from a square. Okay, if you make a square, it's easy for you to calculating the regular octagon. So question number 228. So we have the 12 points are equally spaced on the circumference of the circle. So we have 12 points on here. Okay, so how many chords can be drawn that is connected? Okay, so you can think, okay, the 12 is basically is the dodectagon, right? That's that's we cutting into the angle into the 360 divided by 12 is 30 degrees, right? So we do this, and we do the this is each one is 60 degrees, right? And we cut each one here, cutting each one here, and cutting each one here, right? So okay, so now let's see. Okay, so this is the, let's see, it's the A1, and this is the B1, and this is A2, this is the B2, this is the A3, this is the B3, this is the A4, this is the B4, this is the A5. This is the B5. This is the A6. This is the B6. Okay, so now let's see, because I mean, you know, each angle is this is 30 degree, this is the 30 degree, right? So AA2, A1, A2, A1, A3, then A1, B6, A1, B5. You cannot be greater than the radius, right? So what you can do from the A1, you can pick the A4, A5, A6, right? And you cannot pick B1, and the same thing is B2, B3, and B4, right? So this is the points you can pick from A1. So it's the 6 point, and from the starting point is 12 starting point, and each segment you counting twice, right? From both either one of the vertices. So that's why you divide by 2. The final answer is 32. So 229. So we have a regular polygon, and we know the ACD. So when we deal with the angle, okay, we always draw a circle, okay, because the regular polygon is the equally spacing on here. Let's see, this is the A, B, C, D, okay. They have the equal arc, C, D, right? They have the equal arc. So A, B, C, D. Now what we know is the ACD. We know is ACD is 120 degrees. So this arc, okay, this arc, the inscribed angle is 120, so this arc is 240 degrees, right? Now we know this arc is 120, because 240 plus 120 is equal to 360. That's a circle. So this 120 degrees has been divided into 3 equal arcs, right? So each arc is 40 degrees. So now you can see if each arc is 40 degrees, so 360 over 40 is 9. So we have 9 sides, okay?
Daddy.
Yeah. So the next problem is the next problem is the problem 230. So this 1, 2, 3 are evenly spread on the rim of the circle. If 15 is directed opposite to 49, so what is the n? Okay. So we have a circle.
Daddy.
If number 15 is opposite to 49, right? So if you draw a circle, if you can see if 1 is opposite to p, then 2 is opposite to p plus 1, right? So the difference is p minus 1. The difference between these two also p minus 1. So the 49 and the 15, the difference is 34. So now you know if I starting from the 1, right? And my opposite must be 35. Okay, think about it. From 1 is to 35, right? So my last one must be 34, right? And which one is the opposite to 34 is 64, right? It's 68. 34 plus 34, the difference, okay? So that's why 34 plus 34, n equals to 68. The problem 232. So we have the exactly 3 of the interior angle are obtuse, okay? So we know the alpha 1, alpha 2, alpha 3, I think they are obtuse, greater than 90 and less than 180. And what's the maximum number of the sides? Okay, so 3 of them obtuse. So that means the n minus 2, let's say it's n gon, right? Times 180, right? Minus, let's see, I mean, all these are equal, okay? It's 3 alpha is equal to, we have the n minus 3 angle left, right? And times the beta. So now let's solve the n, okay? So the n becomes so n is 180 minus the beta, right, is equal to 3 alpha minus 3 beta and 360 plus. Okay, and so in order to, so the n is equal to 180 minus beta 360 plus 3 alpha minus 3 beta. So this will be less than, in order to maximize the n, right? We want to, let's see, alpha is 180 degrees, okay? So now it becomes the 360 plus 3 of the 180 minus beta over 180 minus beta. So this one equals to the 3 plus the 360 180 minus the beta, right? So in order to maximize it, we want to the denominator as small as possible, right? Yeah, denominator, so 180, we want to maximum beta. So this one should be less than 3 plus the 360 over 90 is 7, right? So now you can see the n should be less than 7. So what's the maximum n? So the max of the n is 6. Okay, so the problem 233. We have a park is shaped of the regular hexagon. Okay, so we have a regular hexagon of the A, B, C, D, E, F. and each side is 2 kilometers. And starting from a corner, let's see, starting from the A, and Alice walk along the perimeter for a distance of 5. So this is the 2, this is the 2. Here she walks to the midpoint of the M here, right? And so how many kilometers from the starting point? So we want to calculate in AM, right? So in order to solve this problem, we'd better to have the AM into a triangle, right? Okay, so now let's connect the AD. Okay, AD is the radius, right? I mean, it's the diameter. So AD is 4. So this is the 1. Then this is the 1, right? And and then we know it's let's see. Okay, so this is a 120 degrees. So this is a 30 degrees, and this is the 30 degrees. So it's a 120 degree here, right? So that's why this is the 90 degrees. If we see this is 90 degrees, and we know this is 2 root 3, so that's why the AM is equal to the 2 root 3 of the square plus this is a 1, right? Plus 1 square is equal to the 4 is 12 plus 1 is equal to root 13. Problem 234. So if sum of all the angles except one of a convex polygon is 2190, okay, how many sides? Let's see its n side, okay? So the n minus 2, right, times the 180, right, minus 1 angle alpha, okay, is equal to the 2190. We try to solve the n, right? So n is equal to, right? So it's equal to the 2190 plus alpha plus the 360, then divide by 180, right? So now let's to keep solving it, okay? Now you can reduce, you can have it's the 14, okay, plus the 30 plus alpha over 180. Since n must be integer and it's convex, right? Remember, it's a convex. So alpha must be less than 180 and greater than 0. So that's why you can see the only possible thing is alpha equals to 150. So n is equal to 15. Yeah. So for the polygon, normally it's the problem should be a little bit simple. Simpler than the triangle, the circles. What you only need to do is control the different inequalities, and the key key point is you need to know the sum of the exterior angle is 360. Sum of the interior angle is n minus 2 times 180. Okay, so that's it for the problem of this chapter, and thank you. Bye bye.